Welcome everyone. Welcome to the part 4 of the KubePwn Kubernetes Red and Blue Team Lab series. So in the last video, we have stopped it here because I wanted to give you gist of each and every attack before moving into the real world environments, means the real world attacking Kubernetes. But before that, I want to cover the web attacks as well. So the very first attack that I am going to cover is the SSRF, which is the server-side request forgery. So if you are from the web application background, you know what server-side request forgery is, which is a serious vulnerability which will allow the attacker, to force the server to make request on behalf of the attacker, which is very particularly dangerous in environments like Kubernetes, where the internal services can be accessed by the attacker. We will see that in a few minutes. But before that, I really want you to explain what SSRF is. SSRF allows an attacker to exploit a vulnerable web application, which will, or let me just grab the lab guide for you, so that when you are, reading about this, you should know that nothing is being, hide it from anywhere. Let me just bring SSRF in front of you. So here we go. So SSRF allows the attacker to exploit a vulnerable web application to send HTTP requests from server to internal services, which are typically inaccessible from outside of the world. And what is the real world analogy? That if your web application is inside a locked building, and only that application can talk to the internal servers, or like metadata servers, Kubernetes API, databases, the SSRF vulnerability will let an attacker to trick the application into poking around inside the building for them. Okay, so which is very, very risky. So why SSRF is dangerous? Because it will allow the attacker to access the cluster internal services like svc.cluster.local. You can query the Kubernetes API. You can access the secrets exposed. You can enumerate pods, nodes, services in the cluster. You can escalate privileges if misconfigured services are accessible. So to simulate this lab, what I did, we can just go to SSRF over here. Here we go, SSRF, and now all the requests, they are in the form of the metadata DB, which I have given it as an example. If you see this is all metadata DB. So if you go to Google and you check how the Kubernetes metadata DB clusters are being formalized, you can get the information. But the very first metadata DB which I wanted to explore is this. So if I go to SSRF and let me just put HTTP 127.0.1 so that I can get the URL formation. Here I go, the URL formation, that after SSRF there is a URL parameter where I need to deploy, where I can run my URLs, and this is my first URL which I wanted to see, which will give me the service inside the cluster. And if I say hello metadata.db, so that I am able to interact with the Kubernetes cluster, it means that this particular web application is vulnerable to SSRF. Now, if you go to KubePwn and if I do sublime app.py, let it open, and if you look for SSRF vulnerability, you can see over here, okay, that yes, this is the SSRF vulnerability. Let me just grab from here. Yeah. So here you go. This is the SSRF vulnerability, that whatever the arguments that you are going to provide in the URL, it will going to interact at the backend of the Kubernetes cluster. Okay. So this is the SSRF vulnerability. The code itself is self-explaining. Now, this is similar like how you are, getting the information from the AWS cluster by using the 169.x.x.x.x, by querying the 169.x.x.x for meta files. So similarly, you can query the Kubernetes for metadata. So now what I did, rather than showing it on the web application, what I did, I have run the curl. I have made up the curl commands, which will do the same thing for me. The very first curl command which I'm going to run is to gather the host name. So the host name of my this particular Kubernetes cluster is metadata DB 765, and this is some random number that is being given to them. This particular command will actually fetch the host name of the container or the pod, confirming internal access as shown in the as shown here. Let's list what are the running pods. So to run pods, the same thing, you just need to do a /pods, and it has given me an error that this is forbidden. The user who is trying to identifying the running pods on the Kubernetes cluster is forbidden. Let's try to list the cluster nodes. Okay, this is also forbidden. Let's try to extract the secrets. And we got a 403 forbidden for this as well. So now to bypass this, there can be certain methods. One of the method is called SSRF training, which to Kubernetes API, which will allow us, which is an attempt as a more advanced technique by chaining SSRF with token theft and Kubernetes API abuse. So let's try to run it as the what we call it as run it as the local file inclusion. Let's run it. If we are able to do it, no connection to adapters we got. So we are failed over here as well. Okay. If this was successful, this would have given If this was successful, this would have given the some steps further to escalate privileges directly using the SSRF. But here we didn't get anything. So what I will do, I will try another vulnerability, which is the file upload. Let's try the file upload vulnerability in the next video. So thank you everyone. Hope you liked my video. Hope you are enjoying it. I will explain the malicious file upload vulnerability in next video. So thank you everyone. Hope you have a nice day.